Hello, everybody. Thank you for the warm introduction. As you heard, I have almost 30 years experience in electronics and computer science, and I'm teaching students and also working with companies, doing some research. So recently, I mean, last couple of years, I decided to gather all this experience in programming, and it was a tremendous endeavor to write a book, but finally I managed this. And after gathering a lot of material and looking what's going on in industry and in teaching programming languages at different universities, so I gathered a couple of, I hope, interesting for you ideas and conclusions. So I can share this with you and we can discuss a couple of things. So we'll be talking about modern C++ and why it is important and how to teach it in these days. So here's the agenda. After brief introduction, well, a couple of words. What should be important when starting a program for a class, classes or semester of teaching, and what's important, and then a couple of practical issues like this 2080 paradigm, teaching basics of C++. So what is important at the beginning, because of the time is shorter, we have more material. C++ is growing and okay, so what is also important is how to provide good examples. So my previous talk about force programming was just one of the examples of elaborated examples for students. And also how to cope with code legacy, with the 50 years of C on the market and code left after these years of programming. So how to cope with this and how to teach, how to prepare students, or how to make them aware of this. And some hints, some materials at the end. So just briefly about my university. So it's quite huge in Poland. We have more than 20,000 of students, more than 2,000 academic staff. And we have a lot of, 5 actually, departments which teach computer science, which we call Informatyka in Polish. So usually we teach languages like Python, Java, C++, C#. My department, I have background in electronics, so I'm teaching electronic students, telecommunication students, but also computer science students, but also from human departments, biology, and other. So let's reflect a little bit on C++. I wrote this in bold because I like C++ and I think it is very powerful and still will be for 4 years. But this is one of the tools. So this is what we need to remember. We have many other languages, domain-oriented languages, but in many computations, C++ is probably the most powerful and versatile. However, this makes it difficult to learn and to teach as well. So I found these images like Maverick, for example. Learning can be very stressful experience, and this first days or weeks of teaching for beginners are very stressful and very prevailing in the final outcome of the classes. So we need to be very keen on, especially the first lessons, not only learning C++, but so this is our teacher's duty to lead the students and to provide the right way, whatever it is. And by the way, also these are examples of machines which heavily rely on C++ code as well. So let's see some statistics. This is taken a couple of days ago from TIOBE. They use different methodology of building this statistics. But we see that on top we have Python, C, Java, C++, C#. So 3 C and 5 languages here, and we see that altogether C, Java, C++ are all well ahead of others. What is also interesting, C++ is gaining in popularity and tends to surpass Java. These are not my words, these are taken from the TIOBE. So, but at my department, we teach all these 3 languages. But the question is, in what order we should teach these languages? So the order changed throughout years. So I will mention this. But we have another statistics from IEEE Spectrum, quite fresh, just found a couple of days ago. And we see in the Spectrum statistic, they use some 9 metrics to show what languages people are programming in. And they use many sources, but prevailingly IEEE websites. And this data is not, you can find more on their webpage. But we see that again, Python, C, and C++ on the top lead. If you go to jobs, trending, they are different. C++ is in the lower position, but that's not the point here. So, well, we can see that it is still important language, and probably will be. So this is not the question if, but in what manner we should approach this teaching. What is interesting, the black horse becomes SQL language, actually. If you take a look here, if you can guide your students what to learn, it's good to know these languages, for example, Python, C++, and SQL, if you are looking for jobs in good, well-paid positions. But regardless of academia, industry, we are all teachers, or likely will become teachers, even at the academia or in industry. So we have groups, and with years we have younger colleagues, and we need to teach them. So this is, we'll share now some more specific details, what to look for, what is important at the beginning. So first things first, organization. So if we organize the classes, what is very important is to know your students, then place the goals. What do we want to achieve? We need to ask ourselves, is teaching C++ different than teaching math, for example? We also need to take care of class organization, time planning, teaching materials, etc. So going into details of these important issues at the beginning, especially the background of the students is very important. If they already had some classes in any other programming language, or they just start, even their background in math is also crucial here. So we need to answer these questions quite well before we design our classes, our semester of teaching, our materials. So this is very important thing. So, for example, it's a different approach if you teach C++ students of electronic engineering or computer science than, for example, of other departments. Yes. Certainly, sometimes we have professionals who want to advance their knowledge. They programmed in C++, for example, 20 years ago, or they come from other languages like C, for example. So how to convince them to use C++, for example, in embedded electronics is also, or maybe we have sometimes very young students, kids. So well, certainly Python is a good thing to start, but we can have more elaborated plan of teaching also languages like C++. The question is why they wish to learn C++, the first question, because C++ is beautiful. Some people think so, but not necessarily. Yeah, it's always the case. So how to well organize the classes? I especially put this whiteboard, or even years ago we had blackboards with chalk, and the process of transferring knowledge was different, was slower. So everything now is faster. If I show some code now, I don't use whiteboard. Students don't see the process of creating software. They see some lines of software. This is not the best approach. So sometimes even better than live coding is take a whiteboard and start writing something, because we all know that writing code is not a linear process. You start from some idea and you write it. Then you go to details, from course to fine details. Be sure what you want to achieve. Have a plan, but react on students' progress and expectations. So this is also very important. We'll come to this issue in a moment, like a Scrum methodology in software. We stick to plan, but we need to react. Also, we need to take care of our teaching group, of teaching colleagues. What's their attitude and experience? So this is also that point. How to plan our time? I like this image. So how much time do we have? Our approach will be different if we have 1 semester or 3 semesters, certainly. So we need to have this broader view of the classes. So the program I will show you in a moment, we usually have in 2 or 3 semesters. Each semester is something like 14 or 15 weeks. We have 1 lecture a week, and we have 2 hours of labs, and then the students have projects. So a lot of hours, but we need to plan this. How to organize the class and the class work? Certainly, we can have persons developing themselves. This is the first thing. But as soon as possible, we should foster teamwork, in my opinion. So people can if they have this basic knowledge, but we have to be aware that the group be well balanced. So not only one person is writing the entire code and the rest is just sitting and watching. Just this is teachers' obligations to accomplish this as well. And certainly they will rely on the materials we'll give them. There is a lot of materials, but also quite bad, quite outdated, and students sometimes are not aware of this. Books are also good, but not outdated. And now some real stuff, some teaching scenarios. So let's go as fast as we can. But before we go into some propositions, what to do with the beginners, for example, let's take a look at this 2080 paradigm applied here to teaching C++, but any subject. It's not reinventing the wheel, but something, if we are aware of these ideas, we can be more productive or more focused on important things. The question is what to start from, what tools, what web compilers, or just use Linux. So these are also important questions. But before that, let's jump to this 2080 methodology. So. Well, if we take a look in Wikipedia, we read that this is Pareto rule 2080, states that in many life situations, 20% of causes is responsible for roughly 80% of consequences, results. And we can apply this in, well, it was Pareto, he was an economist, he observed that 80% of land in Italy was owned by 20% of the populations. This is the origin of this idea. But some heuristic findings, but we can observe this in many situations. So, for example, 20% of workers contribute 80% of results, but also in computer science, in software, 20% of bugs contribute 80% of crashes. So focus on fixing this bug first. Or 80% of CPU time will be spent in 20% of code. So profile that part and find out this 20% of code and make something with that. 80% of users only use 20% of applications features, so we need to focus on these features. So the key observation is that most things in life are not evenly distributed. Some contribute more than others. So this idea will be taken to the problem of the task of developing the most important features of C++ to teach at the beginning. So here is the plot, and linear is blue, and this idea 2080 is. So if we choose properly this 20, 15, maybe 25, doesn't matter. But at the beginning, this initial material, just like this taking off plane, then we can expect good productivity in early weeks of students. So this we should focus on at the beginning. So that's the point of this idea. Yeah. So focus on the important 20%. Show some concept, get a general direction, and then work out details. See what features generate the most result and give them your appropriate attention. Then move on toward the more advanced material and try again to distill another important chunk of information. Well, yeah, you can ask me, did I reinvent the wheel? No, but it's just an idea which can just make us more focused on choosing this 20% of important things. So even if you are fixing bugs in your code, just try to apply this idea. Just find the most crucial 20% of bugs and fix them first. So you will gain probably more than fixing linearly, for example, in the timeline of coming to the repository. And now, an overview of some teaching scenarios. So we assumed our time. I already mentioned this. So what can we achieve for each step? What we do? Define the main goals. Define the minimal set of C++ features for students. We apply this 2080 rule here. Define the least optional features because we react on students. If they progress well, we can do more or vice versa. And the idea is keep things simple, as Bjorn Stroustrup mentioned, creator of C++. C++ is complicated enough, but I am also adding keep things simple and in proper order. So it goes well together. But be agile. We know this methodology from software. So we need to react. We need to think of our students as clients in these big projects. So we need to react on their progress. So these two ideas, also taken from software development methodologies, can be applied in teaching scenarios. Absolute beginners. So what we do with absolute beginners, structure, operation of a computer. So we don't start with the software. I can say that a good software engineer must understand, at least to some level, how a machine is operating. So if we have beginners and a little bit of time, just start from this. They will gain more later if they understand what is memory, how operating memory is different from disk memory, what are cores in the processor, and things like this. Build understanding API. Even go further on into the processor. So usually we stop on this. But if we teach students of electronics, they need to be aware of, they have separate labs for this, certainly. But if they program, they can observe some operation of cache. They cannot directly address cache, but depending on the data structure they use, the cache is behaving differently. For example, operating with vector and compared to the list. So if we know this, we know what is ALU in the processor. That's very good. Okay, software development ecosystem. So before we program, we need to go into this process how to write software. So we write something, then compile what is compiling, then we link, then we debug. If they come from Python, then they don't know this process here. What tools can be used? And certainly at the beginning, this image can be simpler, but then we can go into more details. Explain the steps of software development. So this is also important, not only implementation, point 4, but from the very beginning, we can teach more of actually not C++ only, but of computer science. So what is algorithm? What steps should be taken? This requirement specification, problem analysis, solution design, then implementation, but also testing and debugging, system deployment, maintenance. And for this, from the very beginning, we can convey more knowledge like UML, Unified Modeling Language, show how to express algorithms. So, for example, starting from such activity diagram before they start writing their own software. And now some boilerplate, we can say, main. So just a lot of, this is our first 20% of what we teach, absolute beginners. So amazingly on this boilerplate with some new functions written by students later on, we can do a lot of things without graphical user interface, certainly in a command line, but they can learn a lot of data structures, algorithms, libraries, tools, whatever. They can use different web compilers. They can use IDs and things like this. So we start with main and we explain a couple of things. We use only 2 or 3 data types, like double. We show from the very beginning how to initialize this, how to input, how to check the value with if, some easy logical rules, and how to call the already built-in functions. So this is our template, and we go and we show how to do this even from the web, from any device. You can open. There are a lot of good web compilers for many languages, and this is fast, and you can start with this. But also you can show, and this is very important to teach also, especially students of electronics, different IDs, but also, for example, Linux and how to program in other environments. So what is the minimal list of features? Main functions, certainly minimal libraries include using directives. They need to use it, maybe not understand from the very beginning everything, but how to use it. Printx and values, cout, define and initialize variables from the very beginning. We just put stress on initialization of objects. So usually we start with text and int and double on these types. Then input and conditional if, stud vector we use from the beginning, string, and loops in classical for and range for. So this is the minimum what we define for the beginning. And we can explain through example projects. Example project is, for example, compound interest calculator. Well, just some ideas, counting occurrences of characters in text. So the idea is to have short examples, but showing all functionality of these predefined features, what we wish to teach students. So this is our 20% of features, just to give us this 80% maximum what we have, what we can gain from knowing how to use basic interface of vector, string, for, if, and amazingly you can do a lot of things, even, for example, such histograms, but also a simple game programming without doing a game, but we need to keep proper order. Counting occurrences, it can be, for example, like for you know probably C++ very well, so it's what is the starting program. one of second or third program for the beginning. But also what we are showing at the same time, we are showing the coding style, UML coding style, the approach, the tools, not only the bare features, okay, C++ and nothing else, just to show that, okay, C++ is a tool and in broader view. And okay, this is my coding style, but I'm mentioning that there are different coding styles, for example, putting parentheses or spaces or not, so they can use whatever they wish. But then they should be consistent. So this is important. This is continuation of this. So I can skip this. So you saw just this is the range, new type of form. We use auto keyword from the beginning, just to show. And based on these examples, we are building different variations and different things. So when we go to a little bit more updated teaching model for more advanced, we know that we were basing on the previous ground, but also we can focus on this important 20% again. But what we can observe is the spiral model, actually. So, you know, the spiral methodology. One more, I mentioned agile, now spiral model for software development. But if you think of teaching and entering again the same thing, for example, teaching about vector, then you again teach about vector, but you show more details, more actions, vector or vectors and things like this. So this spiral model is quite an interesting idea. First original proposed by Bern for software methodology, but we can adjust this. I found this even spiral model going up. So we go up or down, but assuming we are teaching and the material will go up. So this is 3D spiral model. But what is important? Repeatedly iterate a set of teaching processes, increasing level of detail. And in the original Bern process, there is risk management. So what is risk management in teaching? Well, certainly just making sure that the students are doing progress. So you cannot go too far if the group is not following on. So scenarios for basics, so not absolute beginners, but we are still in the first semester. Well, just briefly build types. So we add more. We add debugging from almost very beginning. Basic members of applications. So more about. So here are examples of this spiral model. Matrix, for example, vectors. More about string, auto, and when to use it. And from the very beginning, we foster using standard algorithms. But we don't stop students from implementing their own sort, for example. So they know some algorithms from inside. Not only that what is sort is just calling a line. No, sort is there are many sorting algorithms. So we have examples from the classes, from the labs, for students to develop their own sorting algorithm themselves. And we start with struct. Only with data at the beginning, references, no pointers, and no low level at the beginning. And we go with statements, functions, very important. We show a recursive function, but also lambdas, also at the beginning material. They change from version 17 to 20, but we don't go into such detail, just basics of lambdas. And then struct versus class plus constructor and member function. So we add only one function at the time, which is constructor. So this is again about initialization. So basic software testing. So we foster using Google Test, for example, but just for students to be aware of testing once they start writing software, not just press the button and see what happened in the computer. This is not the way. And we end with operators. And if we have more time for extended, we add tuples, structure binding, random, and then pointers, memory operations, especially if we have students of electronics. This is important. intro to embedded systems. So tool chain, CMake, yes. More on arrays, stood array if we have fixed size containers. But again, know your students, their background and needs. For example, students interested in embedded systems, games, or I don't know. So they need maybe a little bit different approach. And another step is adding more advanced. This is second semester object-oriented programming. So again, we can start with 2080. So let's reflect what will be the most important 20% at this stage, at this level of teaching. But we can also, we can teach more. So for example, we can provide some concepts of design, testing, code refactoring, tool, teamwork, or even Scrum. We can introduce this to practical work at labs. So students working in teams. And again, we define the minimal list, but remember we are based on the shoulder of giants. So we can build on whatever was good in the previous stages of teaching. So introduction to object-oriented, full anatomy of a class, so all the special functions, there were right references at this stage, classes with those special functions, move semantics, templates, generic programming, virtual mechanism, design patterns. What are the most important, in my opinion, wrapper and the body proxy, memory management, what is resource acquisition, initialization, and also if we have time, in the second semester, we show also smart pointers as well. And the last group, this is also important, how to teach advanced concepts, what is important at this stage. That depends. It's the third semester, we can say. So design class hierarchies, file system, forward universal references, regular expressions, graphical user interface, system clock, time measurement. Well, you can introduce file system and clock. Before that, it depends on how much time you have in previous. Usually students use some advanced features. If they are interested, even on the first or second semester, they try to use themselves. So, for example, graphical user interface. This is also difficult, what library to show. This is open question, always difficult. To find something good, modern, and quite easily working, and so on. Intro to functional programming, ranges, into the expression parsing, interpreter, for example, how to build the trees, composite, design pattern, visitor. So this form system just came as an example of the state machine part. Basics of power programming. This is the last stage of what we have in this 3-semester program. And there are a lot of good examples. This is very important thing. So we cannot swim without water. So we need to develop good examples. And when I was writing some materials, the book, this is the most difficult thing. If you try to reinvent something to show something, usually it is poor. The best approach is to have a lot of examples from real projects, cut the parts from a real project and prepare to have a short example of something from real stuff what really works. So this is my approach, but this is time-consuming, difficult, and not always working. But what is important in examples, to find examples which can be incrementally advanced. So you start from one version, and then you can add something. Then you can add something, and at the end, the student can add, for example, graphical user interface or something. So what are good examples? Comprehensible, not too long, touch on real problems, can be extended to more advanced versions. So these are my points. So probably can have different ideas. So how a student can use an example? That's important thing. Well, you can compile, just press the button and see the outline. Retype. Well, you can have as an example, the example, then retype. make it run, or don't use the example. Just take the functionality and try to make yourself without watching the code and then compare. And not to be guided by a teacher how to use something. So these are different approaches, or use it as a startup for your own project. This is very important because examples will leave in students' minds some kinds of patterns they will use later in real programming. They will search in mind, okay, I saw such a thing, I can use it with a vector or a string or whatever. And so this is the point of a startup. And student projects, so they work on their own. And very important, when they come with the project already created, the teachers should have time to do code refinement with the student, to show, okay, this is maybe not the optimal construction. Why? This is working, but it will not work if something, or there are memory leaks or something. This is very important. So the student will see, okay, everything is good, but this point should be refined, this should be changed, or can be done differently. So this feedback, this loop. Examples. Okay. For beginners, what we do, a can't play, and we do example. Secret chamber. So we have, for example, this main function only and couple of functions. We don't have graphical user interface, but we can do a lot of things like this in a terminal as well. So we can devise a lot of, because students are interested in something what they can play, or something is moving or playing music or whatever. So these are good examples, just attracting them. Yeah, some can just devise things like this. For more advanced learners, matrix is a good example. What we use, certainly you can find implementations of a matrix, but vector of doubles is enough, but explain how to use it. Then we can make a wrapper upon this vector and make a matrix. Then we can make from a matrix a real class, just putting data into private. So if we go like this, well, this is our vector, and this is our data type, and here we have the matrix. So in 4 lines of code without include, not counting include, we have a matrix. Easy. But is it easy to use in real, for example, production code, a matrix like this? Well, how to initialize it? If I want a matrix 3 by 4, and explain to the students how to make it, because it will be empty if I make it like this. And also the rows can be different length. No? So maybe a better idea is to make a wrapper and put this vector matrices into a structure. And show that we have a separate design pattern, a wrapper, and show a constructor which will construct the requested number of rows and columns and initialize data. And also we can show some post and conditions like programming by contract. So we convey more information to the students. And then, go faster, we can show some manipulation, some matrix multiplication with this structure. So we can teach algorithms, we can teach again programming by contract here to check some conditions. Then we go to the class. So if you go to the class, we'll make data private, like the encapsulations and all. But now everything is changed because we need to provide the functionality in the interface. So we need to write whatever was in the structure public, but we need to add overload operators, subscript operators, and begin end. So this is for advanced, so we can explain iterator at this point, and also operator overloading quite well. So matrix is a very good example. You can build up on this. Certainly you can go. Yes. So this is more advanced learners. I will just skip fast through this. For example, we can use the currency exchanger, which is just multiplication. If you change from Bulgarian left to Euro, for example, but you can build a more elaborated version, terminal version of even with GUI. Well, you can do something like this, but then you go with some UML. At that time, you can show more design into this project, how currencies are really exchanged everywhere. So we don't have one ratio, we have one chosen reference currency and so on and so on. So if we build such a thing, we can show data structures to store all these records about. We can show stud map to the students and some UML diagrams to design the classes to hold all this information, explain the namespaces, and build. Well, you can find more code, and I'm not going into the code. Also, we can finish with advanced labs, showing some components, building some communication with HTTP protocol, and ending up with, for example, graphical user interface, showing some components and showing how it is good if the components are separated, so we can reuse code. So you started from the one component, then if it is written correctly, it can quite easily be used in such. So you have a boilerplate, a template, because you can change this idea to store any information. So this is a simple database, actually. Code refinements. I already mentioned, so I will skip this, but the most important thing is this cooperation between teacher and the students. So code review, we can teach advanced student code review, but also we can think of pair programming. So this is another methodology, software methodology, which we can put into advanced classes. And mentoring, actually. Well, the important thing is the work didn't start today, so we have legacy code and how to prepare students for this legacy code. What are employers' expectations, which is also important. The students should find their job and progress with whatever software we already have in many companies. So we have dozens of projects in every company and built for years. So we need to teach also lower level at some point. So this is the matter of what, but even explaining main on what these stars are here, they stand for pointers. We need to introduce pointers. And also we teach C, but after the course of C++. Many years ago, we started from C, but now we changed. We start, as I mentioned, with vector, with force, and once the students have good habits of programming modern style, then we go gradually to lower level. This way. Also, we teach Python before or after. It depends on background. So yes, basic of CS. This is right. Well, maybe I will skip to the materials because the time is passing by. But what is important? Teaching materials in a moment, but learn when we teach. So we need to care about our own development because C++ and every technology model is changing so rapidly. So we need to constantly increase our skills. There is this SG20 group. I'm helping them as well. So we are writing some guide proposal for study group C++ education. So we can take a look at SG20 group on the internet and see what these guides are about. And finally, literature. Certainly CPP reference, but okay, we know this, we use it, but students probably cannot teach only from this material because it is very dense. So usually they go for Stack Overflow, but first thing we need to make them aware is the date of such a post. Sometimes they use the code 12 years old with just bad code, so they need to be aware of this as well. Yes, we can have a lot of troubles with old code. A very good thing is C++ core guidelines, but also not for absolute beginners, but gradually. So So let's provide this page for students so they can gradually read. Well, other websites you can find, no problem. What about books? What I was recommending, but these are outdated a little bit. So certainly Strauss-Wood book, but this is 1,300 pages or something. This is also outdated. But these are very good books. So this is what I'm recommending. Nico Yosut is writing, just finishing his new update to this book, very good book. And finally, my book also, you can find all these ideas I presented today are in my book. Well, I divided this into 3 semester plans. So the chapters are organized like this 3 semester classes. And also you can find code on the GitHub. Well, some examples as well. The quality of software of the future depends on the quality of education, certainly. So we came to the conclusions. Our students and many of us become teachers. So what is important, again, know your student, their needs, and we should then well organize the classes. Think of choosing the right features to teach with this 28 rule in mind. Provide good and practical examples, very important. Keep things simple in the right order, but be agile. Teach in a repeated manner, increase the level and the technical whether we can apply, we can have in mind that it goes like this. But very important also is to provide this broader view, not only teach C++, but C++ and computer science and the entire frameworks of software design, UML, data structures, algorithms. Usually we have different classes for this, but sometimes the time is short now than compared to 20 years ago. So don't forget about the programmers companies, the legacy code, and keep on self-training. Always increase skills of your team and yourself. Thank you very much.
Thank you. It's a very interesting presentation. Okay, I will open the time for questions now, and maybe just to start, I will try to put some questions. One concern for me, which is important. Can we really teach C++ to absolute beginners? From my conservative point of view, computer architecture, algorithms and data structures, or at least C at the beginning, should be somehow present before learning C++. What's new now? This is the first question. And the second question, you said for some books, yes, they are a little bit outdated. We should, from my point of view, we should quite strongly differentiate between the things that are invariant on time and the things that are changeable. It means about technology, some details, concept about memory management, and so on. But some things, especially from the point of software engineering and software discipline, let's say, are invariant. So please, open the discussion.
Sure. So beginning from beginners, the answer is in your question a little bit. If you ask why they come to you, why you teach beginners, you don't force them. So if they are from high school, for example, I have students, learners from high school as well, because they are interested in technology. They want to do Arduino, for example, and they want to do something more. Not only Python, they see that, okay, Python is maybe working, but they want to do something more. So these are enthusiasts. And then you start from looking up what is their background, and you can teach a lot of good things to kids like this. Starting from showing these images of how computers built inside. Also, this works for Arduino or PC like this. So we can build from this, and they are quite clever that they will grasp.
Nothing effective.
And addressing the second question about the books is very difficult because you are right. Some basics of computations are the same, but the language, especially C++ in this moment, is changing so rapidly. In my opinion, too fast. It is not settled. For example, some Lambda features made in 17, version 17, were changed in version 20, were updated in 2015 because someone observed something is not working in some countries, whatever. So, well, that's the point. Certainly, if you teach some for range basics, they are quite changes there. But if you go to Lambdas, for example, well, the old book will say something what doesn't compile now, and so this is actually why I came with this new book, because if there were many books I could recommend, that's fine. But certainly my book is version 17 and 20, and now it's version 23. So the problem will be always open.
Yeah, but there was a big big
sure.
17.
Well, if you teach quicksort, for example, it will be quicksort in any language. So you teach the ideas, showing some tools, and the tools change quite fast.
Thank you very much. So that was the question for me.
How much do you think it about 22, and how much do you think of like 600-page comprehensive do you need to read theoretically, like if we go to your beginning?
Yeah, that's the first question I asked myself starting writing. This book is 650 pages, just up to parallel programming. So I managed to make it like this, but it is not the matter of pages of the book. Well, this is not for students. Just you will not ask them to read from the beginning till the end. So, for example, the book by Strauss, the C++ programming language, is wonderful, but it's mostly about C++ 11 because it was last issue was 2013. And it is 1,400 pages or something. So certainly it can be used like a reference, and many things will not work, as you asked, because they are a little bit outdated. So just finishing my answer, just for the classes, you have to prepare, even if you base your lectures on some materials, you have to prepare excerpts of ask students, okay, read from this book, these pages, from this book, these pages, from this web page, and from my web page, this. So that's my idea.
Do you think it's a digestible size of what they need to learn theory first before they can reach 20%?
Not necessarily. It is not. I would not go this philosophical way of analysis and synthesis after 20 years of teaching. Just start with practice. Because this is why I mentioned this takeoff, this start is very important. If the students will catch this wind in the sails, then they will go with smart ideas, good examples. So this is why I repeated many times, know your students, because then you can aim at their needs.
Teach by examples.
Yes, the only way, like teaching the foreign language.
And then I have another question. What are your experiences from teaching online during the COVID?
Online?
Like now, during
Yes. Well, not too good. Well, certainly, okay, the lecture, no problem. I had even more students on the lecture because they could find time, connect from wherever they were at the moment. But doing lab classes is a nightmare because you wish to show something on someone's computer and you see only their code and you need to tell the student, okay, in line 13, change this to this, and he or she is trying to change this in the wrong way, and you cannot, well, maybe it is technical thing to just be able to enter something on the computer. We can, there are tools like this. You can grasp the desktop of someone, but it's not working if you have the group of 20 people. Yeah.
So teaching is very much about the connection between.
Yes. This is very important. So
like I'm in a big global company also. extremely global and distributed. So I'm thinking about the things about when we should teach you big engineering workforce that is scattered in 3 different continents. You have to do it online, and that's a challenge.
Sure, but in such a case, you should ask them to prepare some theory by themselves. You can give a lecture, you can give some exercises, and then meet 1 to 1 or 2 persons maximum, and just try to do something if you have no other means.
Thank you. So you have a question? One more question, please.
I'd like to go back to the beginning of the presentation. Ask you,
So when we
if a student asks you why he or she should learn C++. You have said that this is one of the most popular languages, but this is not an inherent value in C++.
Sure.
So does the paradigm of a language matters?
Yeah, but you are correct. Yes, that's not.
The question is why someone should learn C++ other than because others.
You can show such examples. Certainly, if someone is doing MLAI, just scripting, you're not convince very much someone, well, if they are willing to learn C++, that's fine, because on the background of these libraries are C++. But so know your students. For some reasons, they come to you because, for example, they are doing embedded systems, because they are from electronics.
But it's not always the case. Sometimes they came because they...
This is in the program.
Yes.
This is in the program because these are studies of electronics, and in electronics you do some embedded systems, and to do embedded system you need to stand up operating system, and operating system is written in C, so you need to connect your program to that. So this is the reason why we teach in this way.
Yeah, but there are certain features of the language, for example, whether it's Python or embedded.
Yeah.
Are there any advantages?
Sure.
We could describe of a C++ or other languages in that?
Yes. The first, actually, now I understood your question. Certainly, the first thing you say is what is the anatomy of this language, so that you compile to the machine code, which is different from other languages like Java, Python, for example. Python is interpreter. So we explain what is compiler and what is interpreter just on this image about the toolset. So if you say C++ or C before that, you mean performance. Yes. So any heavy computations, real-time systems, you think of C. Back years, maybe today a little, but I fostered for years using C++ in an embedded systems as well with good chances, because processors are more computationally powered today, so we can use it. And also you can mention different things about programming in language, object-oriented programming. You can react quite faster on errors. Testing can be easy. You can reuse components if you use object orientation. So C++ comes with all these modules inside. And last thing, you don't need to teach everything from C++. You need to choose the good features from the beginning.
Thank you. I would love to have some discussion.
Sure. I'm here till Thursday.
Yeah, thank you very much. So I must stop a discussion now, because we need to follow our timeline, because this is the last session, and we should start from 6:45 from here to the other place. So thank you very much again.